Let's look at this in some detail. Suppose we have a method called getResult that takes two Boolean arguments. It returns 0 if both conditions are true or if both conditions are false. If the first condition is true and the second condition is false, the method returns a positive 1. If the first condition is false and the second one is true, then the method returns a negative 1. You should be able to convince yourself that this is a correct implementation of the getResult method. X starts out as 0, and if both conditions are false, X is not modified, so the method returns 0. If both conditions are true, then the modifications to X cancel each other out, and again, the method returns 0. If only condition 1 is true, X gets incremented, and the method returns 1. If only condition 2 is true, X gets decremented, and the method returns negative 1. Now let's write a unit test for this method. The test case given here will pass. The question I have is, what will the coverage look like? In common test coverage tools like ECL-EMA, there are 3 levels of coverage for a line of code. The first level is green, meaning that the line of code was executed or exercised during the execution of your tests. The next level is yellow. If you see a yellow highlight, it means that the line of code contains a conditional, and only one branch of that condition has been executed. All conditionals have 2 branches, a true branch and a false branch. If a line of code is yellow, one of those branches was never followed. The last level is red. Red means that your test cases never exercise that line of code at all. So my question to you is, what are the levels or colors of the 4 lines of code in this method? If the only test case that is run is the one given here. I'll give you 5 seconds to answer that question, starting from now. Ready? The first thing to notice is that all lines are executed. In other words, there won't be any red lines. However, both of the lines with conditionals will only have one of their branches followed, the true branches. That's because we're passing in a value of true for both conditions. Since coverage tools like ECL-EMA color the background of the executable lines after the tests are run, the result would look something like this. Though a statement is not the same thing as a line of code, when people say statement coverage, they typically mean line coverage. In this example, the code would have 100% statement coverage, but it would not have 100% branch coverage. To get 100% branch coverage, both branches in all conditions would need to be covered. In our case, there's an easy solution. Add a test case that exercises the false branches for both of these conditions. And this is what that would look like. We simply pass in false for both arguments. Since condition 1 equals condition 2, the expected result is still 0. So this is wonderful. Both of our test cases pass, and we have 100% statement and branch coverage. Conclusion, maybe testing isn't so difficult after all. Unfortunately, there are still room for some problems here. Since all of our test cases pass and we have 100% coverage for statements and branches, you might feel comfortable concluding that the given code is correct with respect to its specification. And just for clarification, I'm referring to this description above here as its specification. And if you said the implementation is correct here, I would absolutely agree with you. The code does behave correctly. However, I could give you another example where these exact same test cases pass and where I get 100% coverage from both statements and branches, but the code is not correct. Now, I would have to change the code to do that, but I wouldn't have to change it a lot. In fact, I claim that I can change a single character in this code and still have both test cases pass and still have 100% coverage, and yet the code would not be correct. Please pause the video and see if you can figure out which character in this code you would change to get incorrect code without changing the test results. Ready? Okay, I said you could do this by changing only one character, and that character is X. Instead of returning X, we simply return 0. Notice that both of these test cases have an expected value of 0. So if we always return 0, both of them will pass. Furthermore, the code coverage hasn't changed. All of the code is still covered with line coverage and branch coverage. The problem comes, however, when only one of the conditions is false, but not the other. Then the expected value is either 1 or -1, depending on which condition is true. But the actual result will be 0. Therefore, this code is broken.